there! Let's see here all tools and features used to make 3D projects with Autodesk AutoCAD 2017. Please leave us comments to improve our future video guides. In the previous videos of this guide, we have seen how to work inside a 2D workspace. This has just two possible directions, the horizontal one indicated by the red x-axis and the vertical one indicated by the green y-axis. The 3D view cube in the top right corner shows just the top face, which means checking your project from up to down, whereas your pointer is a simple white cross. To start making a 3D project, switch to a 3D environment clicking on one of the 3D view cube vertices. You will see the gizmo system and your pointer showing an additional blue axis, called z-axis, used to represent the 3D object's height, while the x and the y axes do fix the ground plane of your workspace. In this 3D point of view, you can still use all the 2D drawing tools seen. For example, to draw a 3D shape, you can start from a 2D rectangular base, adding height by using the line tool, drawing lines along the new z-axis. Then, you can close the shape with another rectangle or a polyline. To edit the object, you can still use the Modify tools as seen in the previous video. To check and preview your 3D project, you can use the navigation bar and the 3D view cube on the far right. The 3D view cube is used to check a standard point of view. Click on the vertices to check the most important 3D perspectives. Click on the sides or on the faces to check a 2D perspective view. Use left, front, right, back, and bottom to check your 3D project from such point of view. Click and drag on the 3D view cube base to rotate respect to the z-axis. If you prefer to rotate in 3D freely, use the Orbit command on the navigation bar and click and drag on your workspace. Use the Escape key to finish. You can use 2D drawing tools to draw 3D objects as seen, but this is not recommended since these are quite hard to manage. In fact, circles, arcs, and polylines always spread through either the x or the y directions only, so you are never able to draw these objects along the z direction. Just the lines are able to do so, and another 2D object called 3D Polyline tool inside Draw. These 3D polylines are just like the 2D polylines, with the difference that you can spread these along the z-axis, but you can't make any arc or curved side. The only way to draw all 2D objects through the z-axis is to rotate the main gizmo system. In fact, if you rotate it, you will also change the orientation for the x, the y, and also the z-axis. This allows you to draw 2D objects following this new orientation, so along the old z-axis orientation. This is not the only problem with 2D tools. Even more, you can't use the hatch command properly inside a 3D environment, since this works just on a closed path that lays completely on the XY ground plane or any plane parallel to it. Plus, this does not fill any 3D volume at all. To create 3D objects, you don't have to use the 2D drawing tools. AutoCAD has very powerful 3D drawing tools that are hidden by default. You can show them by right-clicking on the toolbar on top and then going to Show Tabs and 3D Tools. Under the Modeling section, you have 5 main tools to draw 3D objects quickly and easily. The first button from the left is used to draw the most important regular 3D objects like cubes, cylinders, cones, and pyramids. Just choose one from the list. Most of these regular solids are drawn through 2 steps. At first, you have to define the 2D base, just like a 2D object. Then, you have to fix the object height through the z-axis. When base and height are defined, the 3D object is created. Always consider the gizmo orientation. The object base is always on the ground plane or any plane parallel to it, just like 2D objects. Whereas, the object height is aligned to the z-axis and gives volume to the 3D object. So, if you rotate the gizmo, the 3D object's base and height will follow the new orientation. All regular objects that do not have a base, like the sphere or the torus, will be drawn by fixing points on your workspace. These will lay exactly in between the ground plane indicated by the gizmo. When you draw 3D objects, just their skeleton is shown on the workspace, and this is because the 2D wireframe view is enabled by default in the top left corner. This sets the way to preview and render the objects on your workspace. For example, choose Realistic to make a quick render, Shaded with Edges to get a quick render and keep the main skeleton, or choose the X-ray to get skeleton and volume on objects with some transparency, useful when you need to check your solids inside. These 3D views do affect all 3D objects only. All objects made with 2D drawing tools will be always represented through their wireframes only. The second tool used to build solids from the left is the Extrude tool. This creates 3D objects starting from the 2D objects used as base, by adding extrusion depth along a direction always perpendicular to the base. Select first the 2D object to be used as base, apply with Enter key, and move your pointer to fix the extrusion level. This tool works with any base, even with the ones that are not parallel to the ground plane of the system. The third tool is the Revolve tool, and creates 3D objects by revolving a 2D object around a defined axis. Select the 2D object to rotate, use the Enter key, and then fix 2 points on your workspace to define an axis. Make sure to fix the axis outside the 2D object or the tool won't work correctly. Then, once the axis is fixed, fix the angle of rotation to create your 3D object. The Loft tool creates a 3D conductor starting from all the 2D selected sections. Just make sure that all 2D objects to be taken as sections are aligned enough. Use the Enter key twice to finish. In case you need to create 3D conductors with a constant section, you can use the Sweep tool instead of the Loft tool. The Sweep tool creates a conductor taking a 2D object as a constant section, and a polyline path for the conductor path. Select first the 2D object and then the polyline as path. When the conductor is created, the 2D object used will disappear. So save a copy if you still need it before using the Sweep tool. To build custom regular objects, you can use the polysolids. These work just like the polylines seen, but instead of creating 2D paths, the polysolid tool creates 3D blocks on a straight or a curved base, with a fixed height and width on each block linked. When you enable the polysolid tool, check the command line to customize the blocks that will compose the polysolid. Use height and width to fix the height and width for the following blocks. Then, click on your workspace to fix the polysolid vertices. While you draw, choose Arc to draw a block on a curved base. Choose Line to come back drawing blocks on a rectangular base. To close the block, use Close. Remember that the polysolid base behaves like 2D objects. It always lays on the ground plane or any plane parallel to it. Let's see now how to edit objects in a 3D environment. It is better to use the X-ray view in order to check solids also internally. When you select any 2D or 3D object in a 3D view, you get the same blue nodes seen in 2D. For example, in a 2D object, you have the same nodes and commands seen in a 2D view. For regular 3D objects, like cubes, cylinders, or the sphere, you have 3 main kinds of nodes. A central node used to move the object, nodes on vertices used to stretch the object, and blue arrows used to stretch any radius or any extrusion length on a face. Inside polysolids, you can edit the nodes of the basic block and the shape of any arc base used to draw the overall polysolid. Apart from the nodes, you can also use the object gizmo that appears when you use any 2D view, so any except the 2D wireframe one. This gizmo is associated to the current object selected on your workspace, and is used to edit your object precisely, according to the three main X, Y, and Z axes seen. By default, this gizmo is used to move the selected object according to defined directions. For example, if you click on one of the main axes, you will be able to move the object just along such direction. You can also click on a defined plane in order to move freely along such plane, so keeping constant the object position respect to the third axis. If you need to scale or rotate along axes directions, you can switch to other gizmos going to Selection under the 3D Tools tab. This gizmo system can be also used on multiple selected objects. Apart from the gizmo system and the nodes, you can edit your 3D objects by using most of the tools seen for 2D objects inside the Modify section. Remember that these will act always respect to the ground plane only, so on the 3D object base if this has it. For example, if you use the Rotate tool on a cube, you will be able to rotate it respect to the ground plane only, unless you rotate the overall gizmo system of the project. There are also advanced 3D tools you can apply to 3D objects, all collected inside Solid Editing under the 3D Tools tab. Use Press Pull to regulate the extrusion level from a 3D face. You just have to select the face to regulate, and then use the Enter key. Slice cuts the selected object in two. First of all, select the object to cut. Apply with Enter key and then fix 2 points to define the direction to cut the object. When you press the Enter key, choose which side to keep, or if you prefer, decide to keep both cut sides. Fillet and chamfer, as seen for 2D objects, is used to shape the edges of a 3D object. If you choose Fillet, use Radius to define the radius, and then click on all the edges you want to adjust. Use the blue arrow to adjust the radius on the object. Do the same in case you use the chamfer tool and setting the distance properly. Some tools are used when you have multiple objects overlapping. Union is used to create a single object from the one selected. Just select all these and use the Enter key. Use Subtract to remove the overlapped parts from a selected object. Select the interested object, use the Enter key, and then select the other object, or objects, to subtract from. When you use the Enter key, you will obtain the interested object without the parts that did overlap. Intersect saves just the overlapped parts from selected objects. As the Union command, you have to select all the objects interested and use the Enter key. Thanks for watching this video. Check out our following guides to discover more about AutoCAD 2017.